Hello again, greetings, Berkshire Guitar Amplifier Repairs, Stuart Smith on the bench, and today we've got a Marshall JTM45, lovely old amp. This is late 1965 I believe, and the customer is saying he hasn't used it for a couple of years, and when he last turned it on it gave a very loud hum, and so they turned it off and just literally haven't used it since then. So I think I could either power this one up and have a listen to the hum. I don't know whether that will tell me very much. I think, you know what, I'll just take the chassis straight out and we'll get it up on the bench, and we can maybe bring it up a bit more gradually on the Variax. I imagine it's still got the original filter caps, and that of course may be the problem. And we also don't know the provenance of the valves on this, so it could be anything really. Let's get it out of the box, upside down on the chassis, and take a look inside. Okay, here it is out of the case. The full model number on this, it's a late 1965 JTM45 Super 100 model 1992 version 3A. I know you were dying to know that, so I thought I'd answer your question. 2 inputs, and then volume control for each. That's interesting. I wonder why that's labelled loudness 1 and loudness 2 and high treble and normal. No idea. Treble, middle, bass and presence, off on switch, standby, and an indicator lamp. Let's flip it over now and have a look on the underside. Before we do that, 3 preamp valves and what looks like 6v6s in this. Maybe they're 6L6s. Not letting on. Unbranded. I would guess being a 100-watt amp, this is they're probably 6L6s, but I'll check. Okay, let's flip it upside down. Have a look what it's like underneath. Here we are underside. Pretty much original. I don't think anything's been changed on this. Old-fashioned top hat diodes, a gaggle of radio spares high voltage electrolytics, 368 of them. They're all 32 microfarads at 450 volts, well past their date, but they look okay. I need to check with the customer whether he wants me to recap. There does come a time when you have to do that. Another top hat diode, this time in the bias circuit. So this is the bias smoothing capacitor, and these resistors here are setting the bias voltage and hence the bias current. So you would bias this amplifier by adjusting the value of this or this resistor. I suspect that's what's been happening here with somebody putting that in parallel. A hideous lump of a capacitor here. It's actually a dual capacitor. If you look at one end, look, it's got 2 positives coming out of it, and just 1 ground, and that will be, it's hard to read, but I think it'll be something like, again, 30, what we've got, 32 microfarads at, it's got some gunk all over it, 50 volts DC, I'm surprised at that. So I think that's probably 32 at 50. Anyway, we can check that on the schematic, and I definitely want to replace that. That really looks like it's been thrown in there, doesn't it? Can hardly believe that's original, but it is. It's got a little bit of tie-down lacing cord holding it in place. The rest of it all looks quite good. We'll almost certainly, if we do a recap, replace that one too. That's just a cathode bypass capacitor for V1. Looks quite clean. Pots are all nice, they don't feel stiff or anything, although obviously we'll be giving those a service. No, all good actually. A very, very nice example of this early amplifier. It's just really a question of do we find this hum and get that working, or do we pitch in and start changing capacitors? I think I am tempted to power it up and see if we can see what's going on. What we didn't do on the top side was to look at the preamp valve, so I'll just pull one of those now and see what's going on the preamp side. Slight confusion about what the power valve is. Here's the power valve, one of the four that's in the amplifier. Here's a 6V6, and as you can see this one's a little bit bigger. Here's a 6L6, and that's considerably bigger than this. So if I had to guess, I'd say it was a 6V6. I might just put it on the valve tester and see if I can guess what it is from its parameters. They bias up differently, the 6V6 versus the 6L6, and I might be able to guess what it is. It doesn't matter in some ways because we want to put the valves in that the amp is supposed to have, and the customer would like a quad of KT66s. But let's see if we can solve the mystery. Right, on my DIY valve tester, I'm going to set my normal 6V6 parameters, which is 25 volts minus 25 volts on the grid and 330 volts on the plate, and we're getting about 30.5 milliamps look of current through the valve. So let's take our known 6V6 out and pop in Mr. Unknown here. And if this current is dramatically different from the test 6V6, we can assume it's probably not a 6V6. Okay, it's going up quite a bit higher. I mean, obviously they do vary from valve to valve. Okay, well that's considerably higher. Let's get these parameters back up to what they should be, which is 25 there and 330 there. That's 47, so quite a bit difference. Let's pop in a 6L6 and see if that performs similarly to this. Okay, there's a JJ6L6 in there. Up comes the current. And if we got about 45 milliamps or something, let's go, yeah. So this is looking more like, yes, that's looking more like a 6L6. It would be surprising if they put 6V6s in, because that's quite a low power valve, and you've got a 100 watt ampere, so why you would consider putting a 6V6 in, I have no idea. So they look like some kind of fairly small bottle 6L6s. They're not marked. I've taken all four out, and they've got no distinguishing features whatsoever. So I think they're 6L6s. What I think I'll do now is take all four out and test them to see if we've got a decent set of valves. Even though we're going to change them, we're going to be hunting this hum, so let's start off with a decent known set of output valves. Okay, surprisingly all four valves came out fairly closely matched. So we've got a matched quad here. Unfortunately one of these, I think it's this one, maybe this one, is loose. The actual glass envelope is loose on the base, so I'm not terribly happy about that. But anyway, there's a good quad of valves there. Oh, what shall I do on this? I think you know what I'm going to do is I'm going to put in a couple of known good 6L6s and a couple of bias meters, bring it up on the old Variax machine here, and see if we can hear this hum and try and get a handle on what kind of hum it is. Is it a smoothing capacitor down? Is it this capacitor down? Whereabouts is the hum? Is it preamp? Is it power amp? Let's make a start on getting some sort of handle on what's going on here. Right, we're ready to set up. I've got the amp plugged into the Variax so that I can wind it up slowly. I've got a speaker connected in case anything happens. Let's see if we get any HT for a start off, and let's see if the valve, these two brand new JJs, start to draw any current. Let's see if we can hear any hum. Right, so we're up to 50 volts AC going in. We're on and we're out of standby. No sign of the lamp yet. Oh, these are starting to get a bit of power. We're up to 100 volts AC going in, and these are sprung to life. We've got a bit of HT. Can't hear anything horrible coming out of the speaker. I'm going to plug a guitar in just in case. A little gentle hum coming out the speaker. 151 volts going in. 12 milliamps one valve, 6 on the other, so it's working. Oh, it's working fine. Alright, well, let's carry on winding up the input voltage, see what happens. Oh, hum went up noticeably when I went up a few volts here. Now I'm up to 200 volts on the input, and there's a very noticeable hum on the speaker. It's biasing up nicely though, there's no problem there. Let's go full voltage. Bias current's fine. HT is high, but it always is on these Marshalls. And the hum is noticeable. I'm sure you can hear it. If not, I'll just take the camera and bring it a bit nearer to the speaker for you. There you go. Pretty horrible, unacceptable hum. What happens when we turn the volume down, or turn everything down? Okay, the fact that we can turn everything down and it's still there, and unplug the input, look, still there. In fact, that hasn't changed a single thing. Kind of makes me think it's on the output somewhere, but you can never be totally sure with these. Here's another little trick. We're just going to pull the phase splitter valve now, and that will isolate everything before the preamp side. Okay, that's interesting, so that does kill it. So it isn't just the power. It isn't just the power side. It's something on the preamp side. It might be that hideously large 32 plus 32 capacitor, or whatever it was there. Didn't like the look of that. Let's try pulling an earlier preamp valve, see what happens there. That kills it as well, interesting. Okay, it's on the preamp side then. And let's see, how about V1? No, V1 has no effect. Funnily enough, this is exactly like JTM 100, I think it was, I worked on very recently. I've just literally finished a video of it. It had exactly the same symptoms as this, and it turned out to be a ground loop problem. Anyway, let's get this up on its other side again and propped up and see if we can hunt down the hum. Right, we're upside down, just waiting for it to warm up and the hum to come. I'm going to make myself up a little test capacitor here. It's 47 microfarads at 500 volts. And I'm going to eliminate, first of all, whether this is a smoothing capacitor problem or whether it's a hum loop type of problem. So I've got positive to positive look, negative to negative. I'm making sure where I dangle it, I'm being quite careful with it. I'm going to try this one first of all. I'm going to clip onto negative. We'll get a bit of a spark as we touch on here. There we go. Okay, so now I've just put 47 microfarads in parallel with the existing cap. It hasn't changed the hum at all. Okay, let's go on the other side of that cap. Hasn't changed it at all. I'm going to discharge this cap like that. Get rid of the charge. Right, okay, not looking like a preamp smoothing problem. Now the way they've arranged these capacitors here is in series. In other words, that's in series with that, that's in series with that, and that's in series with that. And what that does is to halve the capacitance but double the working voltage. So these are 450 volt caps at 32 microfarad. So this capacitor here is 16 microfarads at 900 volts. So that's well, and so is that one, and so is that one. And I think this is the same arrangement here. I think they're joined together there. Funnily enough, I wouldn't expect these capacitors to be suffering because they've had quite a modest voltage on them throughout their life. Not much more than half of what they were intended to have. Make sure you can see that. Sometimes that gets a bit of glare on it, so we've got 575 across the capacitors, and I'm looking for half the voltage on the middle here. So 278 on the middle of that one, yep. 289, a bit more on that one. 281, so they're all kind of okay. So I reckon these caps are probably okay. Let's have a little look on this one. That's got quite a low voltage on it. I'm not quite sure what these two are doing. 185 volts across there, and in the middle, aha! Now this is interesting. I wonder if we're onto something already here. Now these two capacitors I believe to be in series. I can't really see, they're crammed together there. I'm going to have to lever those apart in a moment. But if you have a look from one end to the other. Oh, okay, that's interesting. Well, that wasn't what I had a moment ago. Oh well, not sure what happened there. Anyway, they've got 400 volts across them, and in the middle 200 volts ish. So again, they're okay. Not sure what I was measuring there. Never mind. Right. Okay. So I'm not really suspecting, you know, a smoothing capacitor problem here. I mean, if we want, we can try our capacitor trick again. I quite like a few sparks. I'm sure you do too. So let's click that on there, and this will make quite a. Let's go halfway. It'll make quite a spark as it charges up. There you go. No change at all. Now we're going to go to double the voltage, so again we might expect a little more spark. We did. No change in hum. You may not be able to hear it, I can. I'm going to leave that cap charged very tentatively, and now I'm going to go onto here. That saves me having to charge it up again with a big spark. Let's go top end. No change in hum. No change in hum. No change in hum. Now discharge the cap. Now that's interesting. Huh? I discharged the cap to ground and the hum stopped immediately. Is it actually working, amp? Huh? What happened there? What? I can hear all kinds of... Ooh! Yeah, it's working. Well, there you go. That's how to cure hum on a Marshall JTM45. You just make a big spark on the inside and the hum just disappears. And that's job done. I think we'll wrap up for today. What the... All I did was discharge a cap to ground. My cap, not even their cap. Okay, alrighty then. This amp is oscillating when you turn up the presence control as well. It's giving a very high-pitched squeak. Right, now I've no idea at all why that hum has vanished. Let's just have a little poke around in case. I mean, it is humming, but it's nothing like the level it was. Well, I have no idea, I'm afraid, why discharging that cap sorted out that hum. The only thing I can think of is we put suddenly a very high voltage and very high current through the ground. Did that clear some kind of resistance that was there previously? I don't know. There's still a small and unpleasant residual hum. It's livable with, but going on the work I did on the Super PA recently, I've got a great big thick cable here, just a length of cable, very low ohmage, and I'm going to connect the ground of the smoothing caps, which is here, over to an earth tag close to the preamp side. You won't be able to hear this, but let me just tell you what's happening. I can hear the hum. It's got low level. That reduced at 50%. And going on to the negative of this capacitor, reduced at 75%. Let's go on to this negative here. Ooh, hugely increased it. You can probably hear that. So it's amazing how these are both ground. If I were to put a meter on here and a meter on here, it would read pretty much 0 ohms. But putting this cable across makes the hum massively larger. Let's just try. It has no effect. So it's interesting, isn't it? So going to here cuts it to very reasonable levels. So one mod I'm going to do is I'm going to bridge these with some thick tinned copper wire, bring it along here and bond it down to this point here, but probably after we've changed this capacitor. So what I next need to do is to find out from the client what work he wants me to do on this amplifier. The only thing I would suggest, it's all down to money really, money stroke authenticity. If money's no object, you just literally go ahead and change all of these, change that, probably change those two, definitely change that, and I think I'd also put some decent diodes in here, IN 1007s or something like that. And that would be job done for the next 30 years. However, if money's a factor, I think these RS capacitors are good to go for a while longer yet, because they've only got half the rated voltage on them. They've got about 280 volts on and they're rated at 450, so they haven't been overly stressed. Also, if one of these caps goes down, blows up big time, it doesn't really matter. It won't damage the amp. The amp will just stop working, and then we can open it up and we can say, oh well, yep, it's now time to change these. And if that's in 5 years time, 10 years time, then so be it. This is not a gig sensitive amp or anything like that. If that were the case, you'd want reliability. I would change this just because it's a horrible big old beast. I just really dislike it, so I think we'll just go and put in a couple of 32 microfarad at 450 volts in there. We probably ought to just change that 25 microfarad over there as a just on spec. It's now 50 years old, 60 years old or whatever. We could also consider changing these bias capacitors, and I think that would be a good idea. And again, I'd probably change that diode for 1N4007, but it's working fine. I guess this is a little bit more critical, because if something happened to the negative bias, the valves would get runaway hot and eventually, well, it would take out the HT fuse, so again, it's not the end of the world. So I'm going to get onto the client now, find out how he feels about money versus authenticity and all that kind of stuff, and he'll tell me what he wants to do. I've prepared quite a few amps for him before, so it's no drama. He'll tell me what he wants me to do, and I'll report back to you when I've spoken to him. Okay, I've had a word with a customer and we have a game plan. He likes to keep things as original as possible. This is actually a very valuable and rare amp, and so he wants to change as little as possible, which I think is probably good. I think these electrolytics are good to go for a few more years, but only because they've had half voltage on them. They haven't been overstressed. I had an eyeball of these two caps, and this right hand one here is leaking. This is the bias smoothing cap, and there's gunk coming out of that end there, so these two have to be changed. We don't have any choice. This kind of doesn't look original, but it's a hulking great big beast of a horrible cap, so we're going to replace that with 2 single capacitors, and we're going to leave the 25 microfarad cathode bypass cap on V1. We're going to leave the diodes. On the valves, he was originally thinking of having a quad of KT66s, but has changed his mind, and we're going to keep with these existing 6L6s. Eventually he'll sell the amp, of course, and whoever buys it will want it as original as possible, no doubt. To that end, I was going to take a hulking great big bit of green earthing cable to do this bonding, but I've changed my mind on that now because it'll look absolutely horrible. So let me show you what I'm going to do. Okay, I'm going to take a piece of quite thick copper wire. I've stripped this out of some domestic high amperage household cable. This is the earth wire, and then I'm going to run it down here. I'm going to bond each of these together, 1, 2, 3, and I'm going to run it along here and connect it to here after I've changed these two caps, and I'm going to put some black sleeving on it and tuck it underneath the board. So this is going to be on the don't know, don't ask basis. No one will notice that at all. You'd have to be a real aficionado to notice that some extra earthing had been put in there, and that's much better than running a hulking great big piece of green obvious sleeving in there. So that's the plan on that. The first thing I'm going to do now, I think, is to change out these caps. So let's make a start on that. Now it's a question really of whether we can get the caps to fit. I've got some, these are at 32 microfarads at 450 volts. I've got some 47 at 450. They would obviously be better and give a little bit more smoothing. Let's just chop this hideous thing out. Glued in too with a huge wedge of cracky. Well, that's not even going to come out, that. I'm going to need to apply my surgical skills. Some sort of horrible bitumen tar stuff. It absolutely will not break. And it's all over here. God, that's really... I don't think that will come off actually. I don't know whether we can try cutting it up into smaller pieces. I'd quite like to get this out. It's truly horrible. It's cutting quite nicely. It might be a question of pulling it out with... Oh yeah, some bits are coming off, that's good. Really, well, it's certainly doing its job. Right, that's most of that off. Probably don't need to do too much more than that, because the object of the exercise, which we may not be able to do, is to get two of these in. Like so. Yeah, there's not much room in there. So not particularly easy, this. Well, it's not too difficult to get it working. What's difficult is making it look nice. I mean, it's going to be obvious to anyone who opens this amp that these two caps have been changed, of course. Right, I think I'm going to make a start to just get that soldered in there, so that we've got a bit of an anchor point at least. Great, that's that. Yeah, Marshall made in the early days they made many different variations of amplifiers, dozens and dozens of different variations, which is why it's so hard to find the definitive schematic for a particular early amp. And they basically used whatever they could get hold of, and in this particular case they popped off to radio spares to get these HT caps, good old radio spares. But then as things progressed, and I guess they started making more amps, they sourced the caps themselves, so stopped using radio spares. At one point they used radio spares output transformers, and the owner of this amp told me that one amp he's got 100 watt they couldn't get a 100 watt output transformer. Radio spares didn't have them, so they put two 50 watt radio spares transformers in parallel to get the power up. Then of course eventually they sourced their own transformer, so they dropped the radio spares transformer, and on it goes really. But every amp's different. Every time you take the lid off one, you'll see something different. This is a little bit tricky here. I know exactly the best way of anchoring this. I might try and go under there. That's good. Reminds me of brain surgery. I read a book on brain surgery recently by a well-known brain surgeon. Oh my god! I tell you, you don't want to have brain surgery if you can avoid it. Right, we've got lots of anchorage there, so that'll give us a good bond. Let's get that one in. There we go, that's good. Okay, that's alright. Let's see if we can make this look a little bit nicer. The answer is no. I think it's probably as good as we can get. It's perfectly okay, mechanically and electrically. I'm only looking at the aesthetics really. Right, I think I'm going to change these to smoothing caps for the bias voltage next. Right, the trick here is to remember that since this is the bias side of things, the positive side of these caps is downwards and the negative side is upwards. I'm just going to take these out, and there we go, positive here, look. And can you see the end of that, look? All that gunk. That is a useless cap. And 150 microfarads, sorry, 150 volts, 10 microfarads. It doesn't actually need to be that big. It's only about 50 volts on the bias side of things. Let me see what I've got. Okay, modern development look, 8 microfarads at 150 volts, 10 microfarads at 100 volts. Very slight difference. 100 volts will be fine, but I will do a little check of the voltage across those caps after I put them in. Right, we want the negatives up and the positives down. That's the important thing to remember on the bias side. So we'll put that one in there like that. Right. Just going to tack that in there for the moment. I'll remember to resolder that. Negative up, positive down. Yeah, I'm just temporarily tacking this in here. There we go. We'll resolder those in a moment. Now what we're going to do up here, I think we'll go around here like this. We've got a nice post there, so why not use it? Similarly here. There we go. We'll solder those properly. Voila! Let's get some Zen music to play whilst I'm doing this. This is turning into one of those slow TV channels, which I think we probably need these days. Okay, so double check negative up, yes, yes, and we need to just reflow these because we just tacked those in temporarily. Actually they look good, but let's do it properly. There we go, and this one. And that's that done. I think the next thing is to turn the amp on and just make sure we still have some kind of useful working amplifier. Okay, the amp is on, warming up, starting to pull a bit of current. So we now, whilst we're here, we will bias this amplifier, and to do that we're going to be messing around with one of the, probably that resistor value. I might have been wrong about that one there. My first port of call would be to go for this. I don't even know what value that is, but anyway, let me show you how I do that. Well, if you watched my video on the JTM100 Super PA amp, it's deja vu all over again here. Let me show you how I will adjust this resistor here, which will adjust our negative bias voltage and hence our bias current. Remember, the more negative a voltage you put on the grid, the less current you get through the valve, and the less negative you put on the grid, i.e. the more positive, although it never goes positive, the more current you'll get. And that's adjusted by the combination of this resistor in series with this resistor here. We want a little bit less negative voltage. We've made a lot more negative voltage by stiffening up these capacitors here, so we want to dial that down a bit. I've got what's called a resistance decade box here, which allows me to dial in any value of resistor. I've got it set to 220k. I'm just going to dab that across this resistor here and see what happens to the bias current, and indeed, look, it goes up already nicely to 21 milliamps or whatever. Constant problem with glare on these. I'm very sorry, sometimes you can't quite see the readings. I think that's okay. So we're looking for about 37 milliamps. I'll get the exact bias current in a moment. So we need to come down on this resistor again. Let's try see what 180k does. 180k. Okay, it's still a bit high. 150, 120, 100k. Yeah, we're starting to get up there now with 100k, look. Okay, now here's my Variax setup here. I've got a Variax I can dial up various voltages on. This measures the voltage. See, it's currently measuring 181 volts at 0.1 of an amp. I've got various switches here. I can turn it off and on, basically. I can bypass the Variax or put it onto Variax, in which case now we're variable here on the voltage. Look, it's gone down to 117. Or I can say, no, I'm happy, I don't need the Variax anymore, I'll just quickly bypass it. But I've also got this lamp in series with the output, and that's very useful for checking short circuits. You put it into the lamp position, apply the power, if that glows very brightly, you've got a short circuit on the input of your mains transformer or something. I've accidentally flipped this into the lamp position, and I haven't noticed it. Now that I take it out of the lamp position, we get our full voltage, and we're up to 80 milliamps on our bias, so we had way too much on here, so we can now just start quickly dialing in a bit of resistance here. I'll bring this down to a sensible value. There we go, that's more like it. And we've got 560 plate volts, not 380. I will recalculate the bias, and then we'll have another go at choosing a resistor. That was an interesting sideline. Couldn't work out what was going on there. The lamp wasn't on, of course, because we're pulling such little current, so it didn't trigger me by glowing. We will have another go at the bias calculation by putting in a sensible plate voltage this time of 570 and recalculate the bias. It now comes down to 37 milliamps, which is kind of close to what I would have expected it to be. Good, so we're down at 32 milliamps, which means that we can increase this resistor slightly, decrease the resistor slightly, sorry. 330k, well, the next value is let's try, hopefully 270 will do it. Yep, 270, I'm happy with that. Look, 37 milliamps on one, 37 on the other. Very good, job done. So we now need to put a 270k resistor in parallel with the existing resistor. So let's make that our next job. Okay, I thought you might enjoy a tiny little bit of theory. We have an existing resistor across which we are going to tack a parallel resistor of 270k, because that's what our decade box said. I could just tack a 270k resistor across there, but why not remove this resistor and put a proper resistor in there? And to find out what the value of the substitute resistor is, we're going to need to do a little bit of Ohm's law here, so let's do that. I measured the existing resistor and it came out at 58k. It's probably a 56k gone out of tolerance. So what we need to know is what's the parallel equivalent of a 58k in parallel with 270k? What resistor does that equal? To do that, we apply the following formula: 1 upon R1 plus 1 upon R2 equals 1 upon R total, where total is the substitute resistor we're going to stick in there in place of those two. So let's do some sums. 1 upon R1 is 58, we don't need to put in the 1000. So 1 upon 58 plus 1 upon 270 equals 1 upon R total. Let's plug some numbers in. I do this without getting glare on the calculator, there we go. So 1 divide 58 is 0.0172, so 0.0172 plus 1 upon 270, and 1 upon 270 is 1 divide 270, 0.0037, 0.0037, and that's going to equal 1 upon R total. So let's add these two together. Well, we've got that in already, so let's just add in 0.0172. So our sum there comes out at 0.0209. 0.0209 equals 1 upon R total, which means 1 upon that equals R total. R total equals 1 upon 0.0209. So 1 divide 0.0209 is, amazingly, 47. So we've got a bit lucky there. 47.8, that's 47k if you remember, because these were all, that was 58k, that was 270k, so this is 47k. That means that if you had a 58k in a 200 in parallel with a 270k, you could take it out and put in its place a single 47k resistor. That's what we're going to do, since it worked out handily. If it had come out at 42.9k or something, I would be thinking, you know what, let's just bung a 270k across the existing one. But it worked out nicely for us, pure luck. Now it's a question of how to do this neatly. There's no perfect way. The resistors these days are much shorter leads than these. These have quite long leads, and this resistor won't reach from here up to there. So what I think I'm going to do is chop that out there and use that bit of wire there. So I'll tin this. Okay, that's one end in nicely. Now I'm just going to make a little hook in this wire here. And then we can take this round here, make a little hook in this wire, like so. And although that wouldn't pass the test of sending it to the moon, it's perfectly good enough for what we're doing here. Job done. Now, of course, the moment of truth. Were our calculations correct? Is the resistor value correct? And what happens when we turn it on? Well, let's get our meters back up. Plug it in. Turn it on without the lamp. Right, okay, well anyway, we've got 33 milliamps, and that's fine. 33 is perfectly okay. Right, so the next thing to do is to... I know what I want to do. Yeah, thank you for reminding me. I wanted to check the voltage across these new bias caps. Because if you remember, the caps we took out were 150 volts and these are only 100. But I believe they've only got like 70 volts across them or something. Let's just double check that. On AC, doesn't help. 61 volts across that one. 80 volts across that one. Perfectly okay. I'm happy with that. 100 volt cap in there is perfectly alright. Good. Now, what else do we want to do? We've got the earthing to do, of course. We'll do that last. So maybe the next thing to do is to have a look at that earth. Now, I know from the previous video I did on the JTM where I hunted an earth hum, it wasn't audible on the video, which is a little bit of a nuisance because you can't hear the hum reduction. So I'm just going to show you the hum now. I'm going to take the camera down to the speaker just so that you believe me when I say it's there. Aha. Now, here's something I want to watch. Aha. Now let me show you something here. I just happened to be twiddling with these controls. As I turned up the loudness on the channel we're in, that's that one. As I turned that up, I suddenly noticed the bias current leapt up. So watch this as I turn it up. Watch this. See that? something's happened there. Just turn the guitar down. Turn the guitar down because we don't need a signal. In fact, we probably don't even need. So something is happening as we turn up this loudness to a certain level. I think for some reason this is not able to read anything. If I were to guess, I'd say this amp was oscillating. And by that I mean when we turn it up to a certain level, we get a very high frequency, huge 100-watt oscillation way beyond human hearing, which is completely trashing the power valves and making them draw huge amounts of current. Is it anything to do with having the guitar in? No, it's doing it regardless of whether anything is plugged in. Let's see if it does it on channel 2. There's channel 2. That's alright, it's working, and we can turn it up full look with no problem. So let's try this again, turn it up, and there it goes. I think that's oscillating. Now the only way we can check that is to put it up on the scope and on a dummy load, so that we can actually see on the scope whether we are getting some oscillation. If we are, that's, I'm afraid, a little bit of a difficult problem to solve as well. Okay, so I was going to let's do the hum first of all. Okay, here we are. It's not terrible, just have a listen. Very noticeable, isn't it? It's livable with, but we know that we can do better with our little earthing arrangement here. So I think I'm going to make that the next job. I'm going to run, if you remember, we're going to run an earth from here now, where we've put our capacitors, hide it along here and bring it up to a bridging point here. Let's have a bash at that. First thing, let's double check all the caps are discharged before we go poking around inside here. We can check pretty much anywhere. Yeah, 4 volts and 7 volts. We're good to go. Mains is disconnected. Now we're going to run this. Now I think what I'm going to do is to do it this way first. So we want about that length. Bend it at 90 degrees. And what we're going to do is we're going to bond this here, here and here. And then bring it along here to here, so this is about the right length. Leave ourselves a little bit flat. Make it nice and straight. Now I'll leave this end floating so that we can bond it here, and then we can turn it on, have a listen, and then just tack that onto there and see if the hum goes down. Because this wire is thinner than the great big thick cable I had before, but I'm pretty confident that it will be okay. I also want to sleeve this. We don't need to because it's just an earth wire and it's away from anything, but I think we'll put some sleeving down here. Let's do that next. Right, I should have put the sleeving on before I bent this, so we'll just straighten that a bit. Put some sleeving on. Will that go on without me bending it more? Yeah, yes, but it's not worth messing with. Let's sleeve that layer like that. So that's going to go to there to there. It's going to come in. And yeah, we now put our bend back in. There we go. And that's a bit nicer, isn't it? Okay, so there we go. We're going to do something like that. Right. Like that. Yeah, I think that's good. Yep, that's a good joint. So now you can see how kind of unobtrusive this is. It's not really very obvious that that's a little addition there. We'll be picking up 3 almost identical earth points here, so we don't have to be too clever about getting things amazingly mechanically secure or anything. I haven't done what I said I was going to do, which was to check it out by touching it on, but anyway, I think I can certainly remember what that hum level was like. I hope you can. And we'll be able to quickly see if it's improved. Yep, that's good. Trying to avoid melting the plastic on these caps. That's good. Right, we've got ourselves a nice earth bond there. Let's fire it up and see if that improved anything. Woohoo, significantly better. Have a listen to this. There you go, that's like 75% down on what it was. Still there, but that's very, very acceptable. Good. Right, we are getting there slowly, and I don't think that's terribly obtrusive either, that earth bonding there. No one's going to look at that and shout and scream. Right, well now we need, I'm afraid, to find this oscillation problem as we turn up loudness 1, is it? Or is it 2? It's not doing it now, interestingly. Oh, that's interesting. Ah, okay, let me show you something. Let me get the camera back on the overhead. Okie dokie, here's input 1. That's working okay. Input 2. Still a little hum there. Oh, input 2, yeah, the hum was there because I'd unplugged input 1 and left the volume up. Input 2. Right, what's happened to our oscillation? Turn up loudness 2. Bit of hum there, but no oscillation. Loudness 1, absolutely max, no oscillation. Let's try the treble and middle. Sometimes they can kick it off. No, treble and middle are up full, and loudness 1's up full. That is now not oscillating. With this on full, there is still some hum there, but I don't know whether we can get any better than we have done. We could have a little play with our great big thick cable again, just in case we can get any improvement. And we always want to come back to this point here. Now if you remember when we earthed this, it was much worse. Isn't that funny? That doesn't improve it. That doesn't, which is good, because we've done that already. Wouldn't expect that to improve it. Let's try these pots here. That does actually improve it. That knocks it down by 50% going from here to these pots here. Not so much this end, strangely enough. No. And then that makes it worse, going onto the ground of here. Isn't that funny? And I mean, it's only when it's on absolutely full. Let's turn up loudness 2 as well. These, you know, these are all completely open circuit, these inputs, and there's no screening here. going down about 10%. Not sure it's worth messing with that. How about if we go from here to here? Same. That's 10%. Yeah. We could put another earth strap from here up to here. Is it worth it for 10% reduction? Do you know what? I think it is. Actually, this is quite long, this lead now. If I just put a short link from here up to here, I think I'll do that. Bloody perfectionist, that's my trouble. If I knew I was getting paid for this, it would be an absolute bonus. Check caps are discharged. They are. Right, so the object here is to bond this onto, I think we may as well go, I don't think I want to go on the back of the pot. I'll go onto this wiper here, which is then in turn bonded back to the pot. Let's just do that straight away, I think, then I'm going to have to start trying to bend and form it round to here. These amps must have been like this when they were made. Hummy like this. Does make you wonder, doesn't it? I don't know how good the old engineers were back when these were made. I mean, they nicked all the circuits from standard reference circuits. It's not like they sat and invented it from scratch. Right, that's just tacked on there. I will come back and reflow that once this is all nice and secure. Although actually that's not bad. Might not need to do that. Now this time I think I'm going to put the sleeving on first. Just an approximate length of sleeving for the moment. There we go. So now we can decide how we want to do this. What we're going to go do, probably got to go down at some point. Not particularly easy this. I might actually have to take this off. Yeah, I think I'm going to have to take this off of here to do the bend properly. So basically we want to come down first of all, look, like that, and then along. Like that, so it's that kind of idea, look. And then since we're doing this, why don't we do it properly? And we want to go in about here. And we don't want this sleeving on the end bit, so we'll just cut that off. So now is that about right? Down. No, now we're down. Oh, I got that wrong. Okay. This wants to come this way. That way. 90 degrees. Is that looking better? Yes, that's looking better. That's looking more like it. Look. We can chop off this end bit. Right, now let's tack this back on here again. I will come along and reflow that. Aha! Hot! Afterwards. so we can turn on again. I hope you recognise there's no rhyme or reason to these hum loops. I mean, when we earthed over to here, the hum increased dramatically, and that's ground too. Let me prove it to you with the meter on continuity. We go from here to chassis. Look, 0.1 of an ohm, look, or to our ground point here. No, 0 ohms. Yeah, I can guarantee you if I connect that to that, we may do it for fun, we'll get a huge increase in hum. Right, so we're on, and that hum has gone down 50% again. That's, oh, we're down on volume. Hang on, so no, maybe not so much. Huh. I'm not so happy about that. Let me just take this off here. See if that improves it or makes it worse. Yes, that has dropped it by 10% as we did in our experiment. Let's just now prove what I said. If I connect this so-called ground here to our new ground here, hear that? And yet we literally just put a meter from there to there and it was 0 ohms. That's hum loops for you. I don't think we can do any better than that without spending, well, I don't think we can do any better full stop. Let's just go back to here and interesting. Wow. Well, this is interesting. So this is what I would call our star earth position here. In audio amplifier terms, you always want to get earths taken back to a common point. I've got everything maxed out. We've got nothing in, so we're in the worst possible hum position. But look, if I go from here to, well, we know, see, that's okay, we've cured that. There's no improvement there. No improvement there. Watch this though. I wonder if you can hear that. That's a 50% improvement again. Amazing. But pretty much anywhere we... Let's go back to our so-called chassis earth here. See, that doesn't improve it. When I go slightly off your screen that way. Right, had a slight battery crisis on the camera there. So if I go from here to pretty much anywhere on the chassis, so we could probably get a bit more hum reduction here by running a more earth strapping from here to here. Interesting. You can't see these earth tags, right? Hey, gonna be here all day, people. Right, there are some earth tags down here with lots of earths going to them, lots of black earths and 2 earth tags, and I'm wondering if it's worth taking those off and remaking them, because I'm now going to go from my star earth to the, well, watch whilst I go to the chassis near it, look, 50% reduction. To this earth tag, no reduction, which tells me there's not a good earth between this tag and the chassis, and here, this earth tag virtually completely kills it. That's all, that hum's gone. But on this earth tag, nothing. Right, okay, I'm going to 100% remove these earth tags, clean them all up and put them back together, and see what happens. I don't know whether you're enjoying this or not. I hope so. It's a long old business, isn't it, trying to locate faults like this, particularly hum. Right, I found the right size nut spinner. I mean, they don't look particularly tarnished, but they, yeah, certainly give them a clean up, I guess. Been 60 years since these have seen the light of day. Right, those are nice and clean now. Let's clean up the chassis where they're bonded to. Not a brilliant system this, but a little bit of deoxit might help, might not, who knows. Right, can we get this screw back in now? It's quite difficult to get out. Right, that's gone back in okay. There we go, good. I'd be very interested to see if that has improved that. Very, very interested. Okay, so we will turn on. Just wait for it to warm up. I'm calling it quits after this. Time for my supper. Now I'm just having a listen. I wouldn't say that that's improved anything, if I'm completely honest. Where's my... Absolutely amazing. I think you'll hardly believe this. I could dab this end onto my Star Earth as always. I can hear that hum quite clearly. So, chassis nearby, 50% reduction on this earth tag. Very slight increase on this earth tag, kills it completely. Isn't that astonishing? Those have all been completely cleaned up. And yeah, if I go onto there, let me see if I, no, shorting that doesn't do anything. If I go from here to here, yep, that kills 75% of that residual hum. Isn't that astonishing? Whereas this doesn't have any effect whatsoever going on there. No effect. And on this earth tag, 75% reduction. Go figure that. Whew. Well, I'm afraid I've just got to run a bit of wire from there up to there. I wonder how thick a piece I need. If I went croc clip to croc clip, would that do it? Interestingly enough, no. Just a little bit. So you need that thick cable, you see. Fascinating. I'm learning as much as you from this. So there. To there. I get on now, which I can't. Virtually, well, it's a significant difference. Nothing on there. Well, okay, well, don't know what more you can do than clean them off and bond them to each other like that. Oh well. Okay, there you go. I've bonded this up to here, and that's reduced it by another 50% or so. I don't think we can get any better. No. Interesting. Now Now going to here, reduce it by 10%. That does nothing, which I'm glad about. Now the chassis is good. Doesn't matter. Slight reduction there. No, I don't think we do a lot more there. Still annoyingly louder than I would like it. We are on full volume. It's interesting now going to here. This tag, remember that tag didn't do anything before, but now we've grounded this one. But not to here, it needs to go back to here. Wow. Doesn't that show you what earth loops are like? We've got a huge thick wire going from here to here, but when I go here, it doesn't reduce it significantly. When I go back to here, it does. Wow. That is extraordinary. But doesn't have any effect here. Ha ha. Wow, wow, wow. Well, you would hardly believe this, and I can hardly believe my eyes here. I've made a bit of a shorter length. That was a bit of a huge cable, that one. So we've got a real decent chunk of cable here. From my star earth to this part of the solder tag, no hum reduction. To here, no hum reduction. Kind of what I'd expect. We've already got a great big thick cable going from here to here. Watch this though. That's killed the hum completely. That is now absolutely hum free. Whereas there, nothing. No change. Absolutely bonkers. And if I short this to here, that has no effect either. So it's not like there's a poor connection between here and here. Whee! Doesn't do it to here. So to this end of the cable, it reduces the hum. To the other end of this really thick wire, no hum reduction. That just shows you need the most tiniest of resistances to cause a massive hum problem. So the question is now, do I get involved in running a separate? Okay, I've run another thick wire from there back to our star earth point, and there's no hum at all. That has completely solved the hum problem. Absolutely nothing compared to how it was. It's okay. Well, there we go. That has cured that hum. But look what we've had to do to cure it. And look how mysterious it is. We had to earth this tag and this tag separately to ground, even though they are 3mm away from a bonded to chassis screw. They were not at the same earth potential. And we had to run this one all the way back to here. So now I guess my only concern is the modifications we've had to do, you know, to the amp. Is this something that's going to worry a future collector of this amp? I guess they can just remove all this if they don't like the non-standard earth strapping. You know, it's all removable. if someone wants to take it back to standard and live with the horrendous amount of hum. But I doubt very much they'll do that. You would have to really know your amplifiers to open this up and say, wait a minute, what's this, what's going on here? I don't know. Anyway, I've done my absolute best on that. The hum is 95% better, and it's virtually silent. Right, so we're pretty much there with the amp. All we need to do now is get the other two valves in and check that it works and that they bias up okay, and that we can get 100 watts out of it. So that's me for the evening. I've been quite a long time on this amp today. I'll join you mañana. Right, here we are 24 hours later, and I'm about to fit a new quad of JJ6L6s. The valves that it came with, as you remember, are completely unmarked and fairly small, I believe, 6L6s, but also one of them, this one here, has a problem with it in that I don't know if you can see that the base is loose. The glass envelope is loose in the base. It works okay. I'm not terribly happy about fitting that though. I thought of maybe running down some araldite or something in here to glue it, but I don't know if you know, but araldite actually isn't very good. That's two-part epoxy if you're not familiar with the brand name. It's not very good at high temperatures. It's got quite a low melting temperature, so it's absolutely useless if you want to stick something that's going to get hot. And I don't really know what I can stick this with, which can take, I don't know, 150 C or something really, very hot. So anyway, this valve is of unknown provenance, unmarked, no idea how old it is. So the customer has decided, I think wisely, to have a new quad of tubes in here. So let's turn it on and see if our bias is... Oh right, we got a bit lucky there, because these aren't the tubes that I had in when I was doing the bias earlier, but they're absolutely fine. Look, we've got 35 and 37 milliamps on there, so that's great. I'll put the other tubes in. These are hopefully a matched quad, and I think I'll just swap the bias meters back to here again with these new tubes in, and we'll just double check that everything's good. Okay, I've put the bias meters on the outside and the other two JJs are now in there. Let's turn on out of standby and see what we're getting. Okay, this one's okay. This one's a little bit low actually. I haven't tested these on the valve tester. I mean, they're all reasonably okay. I think I might just try swapping that one out though for a valve that's a little bit hotter. Let's give that a go. Okay, I've got dozens and dozens of 6L6s all labelled up with the bias current, so I'm just able to go to my store and just pick off a higher current one. So let's see what this does. I'm not saying it's going to work, but yeah, that has come up. Look, remember that's 29. This is 33. This one's going down a bit compared to what these were. I think I might put the other one of this pair in here and see how we get on with that. Okay, these two were a pair, slightly hotter than the quad. Oh, it's coming up now already. Look, so let's just see what that does. Give it a little while to come up, and yes, and that is now. Do you know what? I'm still not. This has come up nicely. This one seems to have gone down again, which is a bit weird. Okay, I'm going to grab an even hotter one to put in here to see if we can get that current up to be a bit more like this one. Okay, I've put a slightly hotter valve in here. Let's turn the standby on, see what we've got. 35 on this, 33 on this, 34. I'm happy with that. It's a couple of milliamps difference. No one would hear a 10 milliamp difference between these valves, let alone 2 or 3 milliamps. So I'm good to go on that. That's fine. So now we can take the bias meters out, put the valves back in, and I think get the amp back into the case. I think we're done on this. I just remembered that the final thing I wanted to do on this amplifier was to wind it up to maximum and make sure it was giving 100 watts out and also wasn't oscillating. I didn't pick up on that oscillation thing again in the video. I forgot basically, but I think the earth strapping has also cured the oscillation problem. That's my view on that. So anyway, here's the setup look. I've got this blue lead goes into the speaker output at the back of the amplifier, and I just have a load of power resistors here, 100 watt power resistors, and I can select on the front 4 ohms or 8 ohms. Currently it's an 8 ohms, and I just, it's a bit crude this, but I just hang my oscilloscope off of the loudspeaker output, and that goes into the oscilloscope, and I can measure the peak to peak signal. Particularly I'm interested in the full power signal, so that will be when the sine wave squares off and cannot do any more work. I'm interested in what is the peak to peak value there. I've got it currently set to 2 volts per division, but my scope probe is times 10 as it's called, so this is 20 volts per division. So currently we are, it's just random, the level I've got at the moment, at about nearly 20 volts peak to peak. So what I'm now going to do is to wind up the level here and count the number of divisions where it squares off. So here we go, it's squared off there, and I make that, well, I don't know, 1, 2, 3, 4 divisions before it squares off. I'm going to turn that down, don't want to thrash the amplifier. So 4 divisions at 20 volts per division is 80 volts peak to peak. We now need to do a little bit of simple arithmetic to convert that to power output. I've done this several times before, but I know not everybody watches every video by any stretch of the imagination, so it's no good saying see my other video. Let me just run through this, skip forward a couple of minutes if you know exactly what I'm going to do here. Here's our sine wave coming out, and we measured it, didn't we, at 80 volts peak to peak. Bottom of that peak to top of that peak. In order to get the power, we need to know the DC equivalent of this sine wave. We know it's not 80 volts DC because that would mean the signal was constantly up here, and we know it's not 0 volts DC because that would mean the signal was down here. We might intuitively say, oh, it's 40 in the middle, but that actually isn't how it works. To get the DC voltage equivalent of this, we take the peak, not the peak to peak, the peak, and that's 40 volts, and we multiply that by 0.707. Don't worry about why, you can look that up on the internet if you're interested. And that will give us the DC equivalent volts of an 80 volt peak to peak sine wave. Okay, let's do that then. And 40 volts times 0.707 equals, I make that 28.28 volts. So 28.28 volts is the DC equivalent of an 80 volt peak to peak sine wave. Now, in order to get the power into a resistor, the resistor is our 8 ohm speaker, or in this case an 8 ohm power resistor as a dummy load, and we've got 28.28 volts across it, and the power is just simply given by V squared divided by R. So the DC equivalent voltage squared divided by the resistance will give us the power dissipated in that resistor. Okay, let's do that then. So the DC voltage is 28.28, so we need to square it, so we'll multiply by 28.28, and that gives us 799. Let's call it 800. 800 divided by the resistance 8 equals 100 watts. So the amplifier is giving out precisely 100 watts. And we didn't see any nasty oscillations on the scope. So I'm happy with that. I hope you're happy with that little explanation, and you can now calculate for yourself the, well, you could if you had an oscilloscope and a signal generator, and if you've got those things you probably know how to do this anyway, so it's just for interest in case you don't know how that's done. Good, we're good to go. We'll get the amp back in its case and sign this one off. Right, well, another one under the belt, a super rare, super collectible and very unusual Marshall amplifier there. I hope you enjoyed having a look inside of it, and I also hope you enjoyed that hum tracking. I was absolutely amazed at that, and I've done a fair bit of hum tracking. Just the tiniest half a centimetre, quarter of a centimetre difference between so-called earth points, and hum either doubles in value or disappears completely. Absolutely amazing. Anyway, we got the job done, and that one will go back into the client's extensive collection of old Marshall amplifiers. I've got another one ready to go up on the bench, so I'm sure I'll make a video of that one. Hope you enjoyed it. Thanks ever so much for watching as ever. I'll catch you on the next video.